is settling in. Welcome to the first data club of this new semester, spring 2026. My name is Moacir. I am the research data librarian here. With me are my three colleagues, Eric, Wei, and Jeremiah is behind the whiteboard. They will be, Jeremiah won't be, but Wei and Eric will be leading other data club sessions over the next 3 weeks. We've compressed data club into just 6 sessions over the course of 3 weeks. So we're going to have another one tomorrow, then another one next Wednesday and Thursday, and the last 2 are the Wednesday and Thursday after that. So we hope that we're trying out a bunch of things. People tend not to come at the end of the semester for obvious reasons, so we're trying to open things up and make things more accessible. So again, take your laptop to the URL that's on the screen, or you can use the URL here, and you should see a presentation that looks like this. And that means that I will probably just get started. So this presentation works by you use your arrow keys to move around, and you can follow along, please. It has the very first slide is just the description. We're going to be talking about starting a Python research project in 2026. So this is not an intro to Python. You'll see a little bit of Python here, but that's not the point. The point is to talk about building a research project and using some tooling for that may be new to you, hopefully is new to you. This again is just the URL for the presentation. And this is a slightly old slide. If we may be using Git, it depends on how much time we have left, to install Git in the, do you need the URL? It's right here. That's a 0, yeah. To install Git, you need to open up your terminal, which on the Mac, this is going to look a little bit weird for me because of the way I have everything set up here. But if you go to the terminal app and open it, you can use xcode -select -- install. So it'll look like this, xcode, right? Nope, xcode select -- install. And this will, oh, sorry, no space between them. And it will say that it'll ask you to install the command line developer tools. This is perfectly fine to install. Most of you have probably done this already on your Macs. If you are on PC, things are a little bit different. Git for Windows on PC, you click on this link called Git for Windows, and it takes you here, and you download and install it. So this is just something you can do while this is all going on. Git for Windows will give you this Git bash shell that is similar to the terminal on the Mac. If you are using PowerShell, then things are a little bit different. The commands are a little bit different. And that makes things tricky. It's actually pretty interesting to see how many Windows machines there are in the crowd here. Usually this is a very Mac-heavy audience. So as a result, I tend to not be as attentive to the needs of Windows users. So we'll see how this goes. Where did the presentation go? Oh. Yes?
So, yeah, I have a Mac, and if the xcode select install is not working, what's a workaround that I could do?
What was it doing for you?
It just told me that the command was not found.
Xcode select?
Yes.
Okay, so you had, and it looked like this, all one word, and then hyphen.
Yes.
Okay. Well, we'll need it for Git, but hopefully we won't be using Git. So again, this is a slightly older slide for a slightly different version of this presentation. But let's see how far we can get without having to run into that problem. Okay, about me, not important. Oh wait, there's something important here. If you learn nothing else today, you learn the email address data@library.columbia.edu. That goes to me, Eric, Wei, and Jeremiah behind the whiteboard. And that is how you contact us for any kinds of questions you may have pertaining to data. And we can help with various aspects of data in your research projects. Data Club, like I said, we have a very compressed schedule. The next 5 meetings are all here. These are all links to the registration pages that you can click on in the presentation. You can also go to our link tree, and that has a bunch of stuff going on in it too, including our Instagram account, our mailing list, YouTube channel, and our WhatsApp group. So ways to keep in touch with what's going on here. Okay. This is my standard disclaimer for this kind of project-based workshops or discussions. What follows is not the only way to proceed. It's not even the best way, but it's an okay way for illustration, and it's a workable foundation, because ultimately the best way to build projects is the way that works for you. So unfortunately, there's no way to figure that out except by doing it. The outline is talking about projects in general. That's really quick. Then I'm going to be talking about UV. Has anybody here used UV before? Awesome. Then there's the Git section, which I'd prefer to skip. And then there's a section on Google Cloud data storage. Who here has experience with Git? A few of you, okay. Who has experience with Google Cloud data storage? Also a few of you. Which would you rather spend time on, Git or Google? Who would rather spend time on Git instead of cloud data storage?
Pardon, could you please define what those things are first? I'm very lost.
Okay, that's perfectly fine. But it doesn't, if you don't know the difference, then the distinction doesn't matter.
Okay.
But Git is version control software, and Google Cloud Storage is a way of saving your data to Google's cloud, which makes it easier to access for research stuff. So I'll jump ahead to the Google Cloud data storage stuff after the UV stuff, and then I'll come back for the Git stuff if it rains. Git is the tricky part that's giving us problems now anyway, or is giving you specifically problems now anyway. Okay. So very quickly about projects. I always talk about this, that your research is not a document. This may be obvious to you all. My background is in English language and literature, where my research is a paper. So it was really tricky for me to sort of reframe my thinking from thinking about a project as just a document, like a Microsoft Word document, and thinking about it instead as a project that has many different parts and pieces that are working in concert with each other. This is a Gantt chart that just sort of explains, if you do any kind of project management, this will be a familiar thing that just shows how long different tasks will take. And there's a LinkedIn course that if you click here in this little bit that's in parentheses here, it'll take you there to watch a project management course. It's like an hour long. It's nothing super fancy. And actually, the main things that you learn from it are to know your constraints. When you're thinking about a project, that means what is the most important thing? There's usually 3 things. You've maybe seen memes about this or something. That a project can be good, it can be fast, and it can be cheap. But it can't be all 3 at once. It can only be 2 of those things. One of those things always has to give way to the other 2. So with a dissertation, you may hear things like the best dissertation is a finished dissertation. In that case, good takes place, is sacrifices to cheap and fast because you want to get it done. But sometimes you don't have a deadline and then you can focus on good and fast, or sorry, cheap and good. Right. So know your constraints. Break your project apart into different chunks. Something like a dissertation, you can break it up into chapters, but you can break it up even further. And that's where something like the Gantt chart comes in handy, because it becomes a kind of to-do list and a way of organizing what you have to get done. And find your blockers, which is to say, understand what in your project is blocking your access to do other things. Sometimes these are obvious, like I can't continue with this project until these lab experiments are done, or until I go visit this archive, or something along those lines. But also it's helpful to see that there may be something much smaller that's prohibiting access to something close by. So, for example, I can't finish this paragraph until I've read this paper. So these are sorts of things that you think about as to-dos, and you put them together, and then you realize what's blocking what, and this is basic project management. So this LinkedIn course, like I said, it's an hour long, and I just told you basically everything that's there. They talk about using some software and about charts and whatever, but these are the key things, to really break everything apart and see how things are related to each other and how they depend on each other. One way that I like to talk about this is by saying that, some of this may seem very obvious, but projects go in folders. Like I said, when I was younger and doing research that was a Microsoft Word document, it was a document, it wasn't a folder. But a project goes in a folder, and this is a very helpful way to think in terms of doing data-based research, or data-driven research, or any kind of similar research, because you want your data, you want your writing, you want your code, you want all of these sorts of things in the same place. And this yields other benefits too, specifically in terms of coding. So concretely, with something like Git or with something like UV, it assumes ahead of time that your project is scoped within a folder. It may have folders inside of it, but it is scoped within a folder. So if you have a master's thesis folder, for example, you may have a folder inside of it that's the PDFs that you have to read, like your literature review. Another folder that's for the data, another folder that's just for what you're writing, et cetera, et cetera. But the reason this is an important way to think about this is because, like I said, tools that help you with this assume this kind of structure. They don't assume that your documents are just all over the place. Like, on a Mac these days, you open up a folder and or you open up a Finder window and it just shows you your most recent documents, like with no consideration to where they're located or anything. That's perfectly fine for using a Mac like a normal person, but for a researcher, that's really, really problematic. You want your stuff all in a folder. And the reason you want that is because you have many resources that have many dependencies. I'll talk about dependencies in a second. And you may have many versions of what you're working on. And the many versions of what you're working on, this is something that Git helps manage, but it doesn't work if you're saving stuff all over the place. You have to be disciplined about putting everything in one folder. Okay, so who here has experience with Python of some kind? Most of you, okay. So like I said, this isn't an introduction to Python thing. We aren't offering something like that this semester. We have videos on the Data Club YouTube page that sort of lead you through Python. But I am going to be describing a tool here called UV. And UV is a sort of a Swiss Army knife tool for managing Python projects. So what does that mean? If you've used Python, you've probably run into programs like pip, most notably pip. Does anybody want to tell me what pip does? Go ahead.
It installs Python packages.
Yes, it installs Python packages. So if you want to expand what you're doing beyond just regular vanilla Python, you need to have dependencies or other packages. So you do pip install polars, pip install matplotlib, pip install, et cetera, et cetera. Virtual env is a little bit more advanced. Has anyone used virtual environments before? Yeah. They lock your project into a specific state of dependencies and versions of Python. PyEnv does the same thing. And Poetry, has anybody used Poetry before? It's very funny. Poetry is very similar to UV, and it's like people are just skipping over Poetry from the old pip-based way of making Python projects straight to UV. UV is super fast. Maybe that's important to you or not. But the thing that is most appealing to me about UV is that it has a lot of these kinds of dependency management type things follow what I call the NPM chaos, which if you don't know what NPM is, it's a JavaScript program which just installs all the dependencies in the folder, and you end up with these gigantic projects because every single new project has this new group of dependencies, and even if they're the same versions of the same things, et cetera, it just eats up hard drive space. And hard drives are free, but they aren't that free. So with UV, instead it uses a global cache and installs everywhere. Okay, so installing UV is, hopefully this will work. I think curl comes installed on a Mac by default. And on Windows, you'll be using PowerShell to install UV. I'm pretty sure I don't have UV installed on this computer, so you get to see me install it myself and see if it works. So I'm installed. And then it tells me to do this thing, but I'll just do this way instead. Oops. Okay. In PowerShell, do all the Windows users know how to open PowerShell?
I don't.
You don't? You click on the Start menu, and you type in, I think you can just type in the search PowerShell. Maybe, go, what's that?
You Windows plus R. And
Okay.
You just enter the PowerShell and it opens the window.
It's this PowerShell.
That's PowerShell, yes.
In
So,
search, I just put PowerShell in it.
yeah. So you would run this command inside of there to install UV. On Windows, this sort of development tool chain is, for me, always much more difficult. For some people, maybe not. For the Mac users, did the curl command work? Nope.
Oh, yes, it did. Sorry.
Excellent. So you may have to close and reopen the shell, and then you can just do UV, and it'll just give this big help file. I think that will work in PowerShell as well.
Did you close PowerShell?
You may, I don't know how PowerShell works with regard to its, how it finds new executables, so maybe, yes.
Closing it and reopening PowerShell works.
Oh, excellent. There you go. Thank you. I'll give a couple minutes.
And then I put UV here.
Yes, and do return.
A lot of it.
Yes.
Directly type that into terminal and Mac.
This curl part. So you can, if you go to this URL, it'll bring up this presentation. You can just move around with the arrow keys. And so you can copy paste.
I just did the curl.
And curl is just a way, what's the relationship
That's it.
to UV?
That's a great question. So I'll explain I can't explain the PowerShell command. This comes straight from UV, but I can explain more or less what the curl command does. Curl, to me, just means like capture URL. I don't know, maybe it actually means something better than that, but to me in my head, it's just capture URL. I'm not 100% what these flags do, but basically the way curl works is you give it a URL, which is this URL, which is a shell script. Install.sh is a shell script. This is actually really risky and like, please trust me, I'm not messing with you about this, but this is generally a risky way of doing this. And then, so curl, grab this install file, install script, then with the result of that command, which is grabbing the shell script, so it has the shell script in memory, execute the shell script using sh, which is just shell. So what this command means is download this script that installs UV and then run it. I imagine this is similar thing here. IEX sure sounds like execute, so I imagine it's more or less the same thing. Again, these are risky ways to install software, so it's best that you trust where you're getting this from, because you are basically downloading a script and saying, please execute this on my computer.
So it bypasses all their security measures.
Yes,
pretty much.
yes, yes.
Good.
Excellent. Okay, so we installed UV. So then what you can do is you can start a new project. So you do UV init my project. And it creates a folder called my project. And I can open this folder. Dun, 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 dun. Where did it go? My project. So this is going to be teeny tiny for you all to see, but it opens up, but it creates this folder with these 3 visible files and 2 invisible files. So if I do ls in the shell, which is, oops. Okay, I should not be doing that. So you do UV init my project, then if you do cd my project, and this should work on PowerShell as well, you are now inside the folder, and you can do ls or dir on Windows, and you'll see the 3 files here, main.py, which is a Python file, pyproject.toml, which is sort of a metadata file that explains the infrastructure of your project, and a readme.md. So if you were doing this for your thesis, you could create new folders with mkdir, so like PDFs, mkdir data, mkdir, I don't know, drafts, whatever you want. And it just creates folders here, or you can create folders how you're used to doing them here. You just do other drafts. It's the same thing. So like I said, README it's just a text file. It's completely blank. So if I do more README, it's blank. There's nothing here. Main.py. If I do more main.py, this is the first bit of Python you'll be seeing today, and among the last. This just does 2 little things, which is it creates a function called main that prints hello from my project. And then if the file is called, and you'll see this in a second, from main, then it runs main. You'll see how that works in a little bit. I could also have opened these files here, but it looks like they would open up in Atom, which I don't want to show you all today. If you have a code editor you like to use, we recommend VS Code here just because it's free, looks the same on all computers, and is pretty straightforward. And the Git integration is very good with VS Code, especially for GitHub. Yes.
What does more do? More result.
More, more in the terminal. I don't know if you have this on Windows.
Doesn't work on
It does. You can try cat. Yeah, cat instead. Main py. More just says give me more of this file. Like show me this file. Cat is show me the whole file at once. Concatenate. I don't know if that will work in Windows or not. Yeah. So, okay. Then there are two hidden files. There's a .python-version file, which it's literally just the Python version, 3 point whatever currently, and .gitignore. Okay, so the wild thing about this is that this should work even if you have not installed Python on your computer. And this is a very valuable thing for me because working in Python is famously, it's getting easier every year, but for years has been extremely complicated just to get it working on your machine because there are versions installed all over your computer that are in conflict with each other and causing all these kinds of problems. This is a way of trying to bring some control over that. Okay, and the last file is gitignore, which I will show you because it's a very important one, which shows all the file types or file names and locations that Git will ignore. What this means is that if you use Git to handle the different versions of your work, then there's things that you don't want Git to know about. PDFs that you may have acquired in suspicious means. You don't want them up in your Git stuff. Derivative compiled software results, software applications. So what goes in build. PyCache has compiled C versions of Python programs. You don't want to save that. There's no point. You have the code. You'll just rerun it, et cetera, et cetera. And as we will see when we get to the cloud storage stuff, we will be downloading authentication keys, which you do not want to put into version control because then if you upload it to GitHub and have a public repository or even a private one and there's a data breach, then anybody can have access to your cloud storage stuff. Okay, so I already talked a little bit about dependencies. If you've written Python before, you've written like import something, that's bringing in a dependency. You have to have that installed. If so, something like polars, or pandas. Polars is sort of a nicer, fancier version of pandas. If you've ever done import polars as PL, that's a dependency. So you have to have those dependencies added via UV. So we can do this here, and hopefully this will work. UV add rough. So rough is a dependency, and you can see it did a couple things here right away. It's saying it tells me what version of Python it's using, or CPython in this case. It creates a virtual environment, which is an environment of different kinds of versions of Python, et cetera, that are located just inside your folder, which again is valuable because then you know what's going on there and it doesn't depend on whatever chaos you have in some other folder or on the machine as a whole. And it installed a package, rough. So rough is a code linter. Like the specifics about what rough does don't really matter, but we added it to this project and now we can run it. And it does its checks and says all checks passed. So hopefully that worked for you. And all it means is it said this code looks like it's going to run, which it does run. And we can check that it runs by doing UV run main py. Hello from my project. So again, that's this, print hello from my project. Yes, Wei?
Once you install this is only for this project. That is the
So the UV scopes everything to the folder that it's in. So if installing UV installs it globally, so to create a new project, you always just do UV init folder name, and it creates a folder in there. Oh, good question. Yeah. So rough is installed only for this project. Yes. It's not installed. You do UV add that, yes. So it's not like R, for example, where you would just like install dplyr and then dplyr is available wherever you start a new project in R. Yeah. So, yeah, go ahead.
I have a question. So if I move the folder to another directory, so what can I do with it?
If you move your project folder to like a different disk or something like that, then that's perfectly fine because it has, so you saw here that it created a virtual environment at .venv. So if I do ls to see everything here, you see the folders that I made, and it made a new file called uvlock. We don't have to worry about that. But also here is a hidden file called .venv, which has a bunch of stuff inside of it that gets carried with the folder when you copy it somewhere else. These hidden files, they move along. So the project becomes portable. Is that what you were asking?
So what about if I want to create my project not in its default default path, I want to create it in another locations.
So if wherever you are, so okay, so here I have this little home icon. This all looks different for me than it does for you, but I'm in my home directory. So this is the equivalent of being here in this folder. I should clean this up for using it on demos. But so I'm in here. So if I go to projects, so that's this folder, projects, and I create a UV init my second project, then there will be my second project folder here. So if you see, this is in Moacir projects, my second project. Whereas the first project is just here. My project is in Moacir, my project. UV init creates the folder wherever the shell is at that time. When you, yeah, oh, if yes, so yeah, so one answer is where the project is created is a function of where you are in your shell. If you want to move stuff around, then that's perfectly fine too. You can just copy the folder and paste it somewhere else and rename it, whatever, it doesn't matter. The dependencies aren't installed in the folder, because remember that idea of the folders getting bigger and bigger and bigger because the same dependencies keep getting installed. They get installed in a hidden place on your computer, and they're just referred to by each project. So the project itself stays lean. Okay? All right. So that .venv is the virtual environment. When you're working by yourself, this sort of thing is typically not super important. But if you're in a collaborative environment, it becomes very, very important because you want to be able to have just give me a second here. There we go. You want to be able to ensure that everyone's using the same versions of the tools, so that if there are features or something, or if something works for someone but doesn't work for someone else, it's often because you're running slightly different versions of the software, or very different versions of the software. And the virtual environment creates a a sandbox where everything is very explicitly described, and it becomes very safe to do this sort of stuff. And the UV lock file that I said we would not worry about, if we look at it, we can see that it's a whole bunch of stuff that talks about all the different things that are in the project, all the different dependencies, the very specific versions, so that all of these different relationships are maintained in a very specific, explicit way. Yes?
It says uv.log does not exist.
It will not exist until you do something like UV add rough. Then it should create it.
Still does not exist.
I think if you can just do UV lock, and that might make it. It may be different on Windows then. Sorry, I don't. Do any of the Windows users have a UV lock?
Yeah, we have it, yeah, like rough or,
Or the UV.lock file.
Yeah.
it's there.
Okay. Are you inside the folder that you were in?
I'm in my project.
Okay, so you should see main.py, pyproject.toml, readme.md, and that's where the lock file should show up. Well, it might.
Oh, it's in .venv. You have to go into that.
Okay, so Windows moved it around a little bit.
I don't. Is it supposed to show when you do ls?
LS, it should show up in LS. So if you just do LS within my project, it should show .venv.
It's not showing for me.
It could be that sometimes in Windows it's set to not show you hidden files. You might have to log into PowerShell as administrator.
That could be, yes. But at the same time, you should not have to worry about your UV lock file. Like it's there to do this kind of meta infrastructural stuff. Okay. How much more do we have here? I will skip bringing UV to an existing Python project. It's pretty straightforward. UV also lets you use different versions of Python. If you do UV Python list, it'll give you all the versions of Python it has access to, which are not the ones that are installed. It's just the ones that it has access to. So let me see. It takes a little bit of time, may take a hilariously long amount of time on this ancient computer. Oh, it worked. So we can see that there are a bunch of downloads available for all these different versions. And these are different Python interpreters. We are using Python 3.9, or I am using Python 3.9. I don't know what it decided for you all. On my computer here, it's using Python 3.15. These are important things. Mostly, you will run into certain software requirements that say must be using Python 3.13 or greater. 3.9 will probably get you most of where you need to go, but you should hopefully have newer versions on your machines. And you can just do Python install and then the version number, and it will install it. And this is a such a simple way of doing this compared to how it used to be. Okay, now I'm going to skip all the Git stuff and talk about Google Cloud Storage. So this is important. I just finished a degree program here where we were sort of expected to just know what Google Cloud Storage is and just use it and whatever. That's not how, it's actually very complex and very scary in many ways, especially when you think about how you are opening up all this kind of potential, like you you have a lot of tools in your hands. So the way you start with Google Cloud, the Google Cloud Platform, is you go to the GCP console, which is here. It's a link. You can't really see that it's a link, but you can click on it here, or you can just Google GCP console, and it'll say Google Cloud Console. And then I have to, so it just brought me here, and I go to my console, and you'll see something that looks like this. If you have never done this before, it may be asking you for all these kinds of things. We don't have time to sort of, it might ask you for a credit card. It might ask, like, this is all just because one of the problems with Google, with GCP, is it costs money. If you have never used it before and you log in with your Columbia credentials, let me rephrase that. If you've never used it before with your Columbia credentials and you log in, it should give you something like $300 worth of credentials, where if credits, where if all you're using it for is storage, will last you a hilariously long time. If you decide that you want to use it to do image recognition with AI, if you decide you wanted to use it to do, weather modeling, you'll burn up those credits instantly. But if all you're doing is making little storage buckets where you can have data like CSV files or whatever that you want to put to access from, if you're working in a team, they all can have access to the cloud storage bucket, and it becomes a place where you can have things that are